Let's look at the volume and the disk. A quick summary of disk. Okay, let's start with the disk quickly. A volume of a disk. And you draw a graph. The graph is like this. And then for a disk method, this is your stripped dx. So you look at the rotation. So the rotation is like this for a disk. The rotation must be in the small thickness for the disk shape. Okay, so the rotation of the disk must be with the same axis as the stripped. So if they say it's rotated in the x-axis, yes, a strip will be in the x-axis will be x, and then the limit will be given. You'll calculate it, will be given, or depends. For a disk is something like it's a volume. It's a volume with like it's a normal volume like this. This is a disk method. So this one represents the value of depend on whether it's x, it's a radius or when, and this one is it represents the thickness. A thickness it's a strip. It represents the strip for a volume. So if you have something like this, a strip will be your height. So and then the distance from here from here to here, it's your radius. Your radius could be the graph. It's the graph that touches the strip. So when you draw your graph, you'll have something like the stick. You'll have something like this. You're given a graph like this. If you're given a graph like this, so your strip is here. So your point of limits are here. So if they use the disk method to calculate the volume here. So a disk method is the same rotation as the x-axis and the same rotation as the stripped. So the stripped, if it touches here, is dx. If it touches here and stripped is dy. So if they say it rotated in the x-axis, that means it's a volume. Volume, we're dealing with the volume. This is a disk method. We're dealing with the disk method. So this one, it's your equation. Depend whether the equation is like a straight line or anything. It's in the first quadrant. So your strip, it's here. If they say it rotated in the x-axis, I mean it's a disk method. And like the disk must be in the same rotation as the rotation must be the same axis with the strip. So it's a disk method like this one. If you rotate in the y-axis and the strip is in the y-axis, then it's a disk method. It is a disk method, so it's x square here. So this like represent r and this one h and pi, so is the same. So you have to draw the graph and show all the points. So if you are given a graph like this, you must know the nature of the graph. This is the nature of the graph. So if you find something like this, it's from the same family. So it's this how I call it. This is the nature of the graph, and this is the same family. This one is also in the same family. It come from this one. This is the origin of the graph, like this one. I call it the original of the graph because it's in the center. It does not have any transformation. If it becomes like this, I call it it's from this family, but it's a transformation. Like which one you can call it? This one. This is the so if you know the nature of the graph, it's easy to draw the other graphs quickly. So you must know the nature of the graph. What can we say about this method? I think it's so for this method, another thing, so if you have two graphs like this, one goes there, the other one goes the direction, and they say which one is the first one. To find the first, let's see, for it you have to calculate it. You need to calculate the graph. No, it's not this method. The same rotation and the same strip. It's a rotational, it's a disk method. So you know it will have something like this. Which one is graph 1, which one is graph 2? So to find that, just draw a dotted line. So when you go up, what is the number here? Let's say it's 1. Here it obviously will be bigger than the one that is here. So this one, it will be a graph number 2. It will be the graph number 2. This one is graph number 1. So you'll put it here like this. It's number 2 is the one on top. Number 1 is the one on the bottom. So the bigger one minus the smaller one. So it's same here. The big graph is the one that touches the top part, and the smaller graph touches the bottom part. So if it's like this, and they say use a disk method, you will have something like dy. This is the disk method. So the rotational frequency must be the same as the strip for a disk method. So you'll have something like this. And if this is the same, this one, that means we'll have x2. So which one is the bigger graph here? Which one is the smaller graph? Just write a dotted line from. So the number here and here, this one is bigger than this one. So you check which one touches the bigger one. This one, it's a bigger one. This one, so this one will be this one, and this one here will be this one. So this is how you find the graph